Hey everybody, welcome back to another edition of No Here, No Problem. I've got a special guest speaker today with me, my daughter Brooklyn.
Hello.
So, Brooklyn is an avid lover of mathematics, just like her dad. She's 9 years old. I will prove it to you. Okay, ready? Brooklyn, what's 185 times 74?
Um, 13,690.
13,690. 185 times 74, 13,690. Put in your calculators to check it. I bet you'll find that she did it right. That's my girl right there. All right. Anything you want to say to everybody?
Just that you'll probably do great in this lesson, and he's going to do great teaching. And
Thanks, sweetheart. Love you.
love you too.
All right.
Good night.
Night night. All right. Anyways, to the lesson we go here. So, the fundamental theorem of algebra. This is section 2.5. And what we're going to be doing is we're going to be taking all the stuff that we've been learning, where we learned how to do synthetic division, long division, using the graphing calculator, complex numbers, real numbers, irreducible quadratics, linear factorization. We're putting it all together now into one big lesson here. Okay. So if you aren't sure of any parts, make sure you go back and watch them, but I'm going to review them a little bit in each section here. Okay. Let's get started here. So we're talking about zeros of a polynomial function. And if you recall, when we're talking about polynomial functions, the really important detail to recognize when we're talking about these is the degree. That degree tells you how many answers there are supposed to be in this, whether there be one real and two imaginary, or three real or whatever it might be. That degree will tell you how many answers we're supposed to get. Now, when they tell you to write answers in linear factorization means that we are going to have x and then minus some value, and then x minus some value. And we call it linear because this term that we see right here, that x has the degree of 1, which makes it linear. If we had it as like a 2 or something else, that would be considered what we call a quadratic. And we'll talk about that a little bit in this lesson here. But let's take a look at first this x cubed plus 4x. If I throw this into the calculator, x cubed plus 4x, this is what our graph is going to look like. Okay, I'm going to actually reset it here back to normal. And it says because the degree of this is equal to 3, that we're supposed to have 3 answers. And no matter how much I zoom out on this, we'll notice that this just only has one answer. Even if I stretch this out, you can see what ends up happening is there's only this one answer that's right in the middle. So if I can only see one answer in this entire picture, this tells me that that one answer is a real answer and that my other 2 answers are going to have to be imaginary. Well, where do those come from? So let's take a look back at this. All right, let's go about just factoring the way we normally would. Let's just factor it. Let's take out a GCF, if we can, and we end up with x times x squared plus 4. If we take each of these factors and solve them, we have that x is going to equal 0, and x squared plus 4 is also going to equal 0. This is one of my answers at x equals 0. And then if I go ahead and solve the other one, it's x squared is equal to negative 4. Take the square root of both sides, we get x is equal to plus or minus 2i. Okay, and that shows us right there that there's 2 imaginary solutions. And if, again, we throw this into our calculator and look at it, we can see that right there in the corner, okay, right up here is where it actually hits at 0, and it's the only spot that it actually hits, okay? Let's take a look at the second one here. Same exact idea. It says find all the complex zeros and write using linear factorization. So let's go back. I'm sorry, I forgot to do that last step, which is to write linear factorization. So if we are going to go ahead and use the zeros that are given to us, here are the zeros that we've got. Okay, we've got 0, 2i, and a negative 2i. Now these are my zeros. To write the linear factorization of this, we're going to write this one as an x. We're going to write this one as an x minus 2i. And we're going to write this one as an x plus 2i. We use the opposite because remember, when we're doing the factored form, if I was to say that x is equal to 2i, that's one of my answers, and I move this over, it's going to become x minus 2i. Just like if I said that x was equal to negative 2i, and I took this and moved it over, it would say that x plus 2i, and that's going to equal 0 and equal 0. Okay? All right, let's continue on here. So if we have x to the 5th power plus 9x cubed, this tells us that there's supposed to be 5 answers for this. 5 answers. And if we look at the calculator, maybe we'll see 5. I don't know. I could tell you, but we're not going to see 5. So let's take a look. You can see this looks very similar to our last graph that we just had. It's an odd degree. And we know that odd functions generally have that behavior where it goes up and to the right and then down to the left, and it still follows that in this. But you can see what ends up happening is right here, we have this point on here, 0, 0. It's the only one. No matter how much I zoom in on this other stuff, even if I try to stretch this out a little bit, you can see it creates more of a gap between my x and my y axis there. And it won't change anything that no matter what ends up happening there, we still are only going to cross at 0, 0. Okay? Well, why is that? If we take and factor out the GCF here, we get x cubed, and then we're left with x squared plus 9. This 0 right here, that x cubed is equal to 0, that 0 is going to count not just once, not twice, but 3 times. It said that, remember that this has a multiplicity of 3 because that 3 there tells me it's going to count 3 separate times. So we've got 3 of our zeros so far. The other 2 zeros are going to come from this right here, that x squared plus 9. If I solve, we get x squared is equal to negative 9. We end up with x is equal to plus or minus 3i when we take the square root of both sides. So now there's 2 more answers. So there's my 5 zeros that we had in this. So we have 3 real, but there's only 1, and that's a 0, but it has a multiplicity of 3. And then we've got that 3i and negative 2i. So the linear factorization for this would be x, and then plus 3i, and x minus 3i. Okay? And we can simply write the x cubed right there. And we've got linear for each of the binomials on the inside there. All right. All right, next one, it says find a 4th degree polynomial with real coefficients that has -1, -1, and 3i. This tells us right here that that -1, -1 is going to count. It's going to have a multiplicity of 2. So if we have x is equal to -1 and x is equal to -1, that means that we're going to have x plus 1 and x plus 1 for the factors. Okay, so x plus 1 to the second part. Well, this 3i, if you recall that anytime you have an imaginary number, you're always going to have its conjugate as well. So if we have that x is equal to 3i, that means we have x minus 3i. The conjugate for this is going to be a negative 3i. So x is going to equal negative 3i. Remember, imaginaries are always going to be paired together. So move that over. We're going to have x plus 3i. Okay, so we can tell right here, just from this, that we have 1, 2, 3, 4. We have all 4 of our degrees accounted for. And so the linear factored form for this is going to be literally what we just wrote right here. I'm going to duplicate this. We're going to move this down here, and this is my linear factored form. I'm going to move these so they're actually closer. Oops. Whoopsie doodle. All right, so this will get moved over here, and this will get moved over here. It's conjugate. So that's the linear factored form. It now says, let's go ahead and multiply this out. So it says to write this in standard form means multiply out. Okay, multiply out. All right. If we go ahead and multiply this out, my recommendation is try to put the real stuff together and the imaginary stuff together. The imaginary stuff will generally cancel itself out. Okay. So if we take the x plus 1 times x plus 1, just that part alone, we're going to end up with an x squared plus 2x plus 1. Okay. If we take the x minus 3i and the x plus 3i and we multiply that out, what's going to happen is we're going to have an x squared minus a 9i squared, which will just turn into an x squared plus 9. So now we need to take this binomial trinomial and multiply those two together to get our final overall product here. So we're going to have x to the 4th plus 9x squared. Okay, and that's right there, just taking that x squared and distributing it to these two parts right here. So x to the 4th and 9x squared. Next, we're going to take the 2x and distribute it out to that x squared plus 9. So that's going to give us a 2x cubed plus 18x. All right. Next, we're going to take the 1 and distribute it out to that binomial there. So we're going to have 1x squared and 9. So we'll have 1x squared and a 9. And then we can go ahead and put things together that belong together. So we're going to have x to the 4th. Okay. We'll have 2x cubed. We're going to have a 10x squared. That's from these two. And then we're going to have an 18x and a positive 9. And this should be our final answer. Okay. Can't remember if I graphed that or not. I did not. But if we graphed it, you would see that we have a turning 0 at -1, -1, and then that would be it. That would literally be the entire answer there. So let's sort it in, just for the heck of it. X to the fourth plus 2x cubed. So x raised to the fourth plus 2x raised to the third. What's the next part there? Plus 10x squared plus 18x plus 10x squared plus 18x. And then plus 9. All right. And so let's see here. We have -1 for the answers for that first part there. -1. We have a turn 0 there. And then I got to turn that one off. So we got a -1 as my turn zeros there because that -1, remember, counted twice. And because it counted twice, it counts as a turning 0. And then look at the rest of the graph. At no point anywhere else can you see it ever crossing again my x-axis. Okay? So that's it. All right. Let's move on. So the next thing is talking about factoring polynomials, and when we get to what's called the irreducible forms, okay? So a quadratic factor that has no real zeros is said to be prime over the reals. So like if I had a, sorry, I got to put in the word here, irreducible over the reals. So what that means is that if I have a quadratic, which we see right here, and I can't factor it any further, we can leave it as an irreducible quadratic. And we would leave it in that imaginary form then in the linear factored form. So we'd have x plus I and x minus I. So it has no real factors. X squared plus 1 is also called irreducible over the imaginaries. Let's not get hung up on the words. Just focus on what we were talking about, that it's a quadratic that's irreducible. If I did try to solve it, I could find the zeros, and then I could then write the zeros in this factored form right here. Okay? All right, let's focus on this, though, now, where it's another one. This one is what we call an irreducible quadratic over rationals. I'm sorry, irrationals. And what happens here is we end up with x squared minus 2, which if I was to solve this, we would have x squared minus 2 is equal to 0, x squared is equal to 2, and x is equal to plus or minus square root of 2. So these are real answers. They're not imaginary. They're real answers. And so we would say that it has factors, but those factors are not rational. And then in this case, x squared minus 2 is irreducible over the irrationals. Again, it's just some words. Doesn't really matter so much. Just understand that it's not reducible in terms of being factored. It's just going to be left as a quadratic. Or you can write it as two rational values if it's asked to be, irrational values if it's asking you to put it in linear form. Okay? So when we look at this one here, it says, let's write the polynomial x to the fourth minus x squared minus 20. Okay. It says to write it as a product of factors that are irreducible over the rationals. So let's look at this first. Here's the graph. And if we look at this, I'm going to zoom back into home here. You're going to see that in this graph, we can see that there's two separate values here that are exactly the same. Okay. There's two real solutions here. And those are the only two that we see. So this is a fourth degree polynomial. I should be able to see four separate answers, but I only see two real ones. So that tells me I have two real solutions and then two imaginary solutions. Now let's try to factor this like normal, if we can. If I given you x squared minus x minus 20, I would assume that you guys could probably factor this pretty quickly. That the factors for this would be x minus 5 and x plus 4. Okay. Well, the fact is that this is actually an x to the fourth and x squared. So the transition that we're going to do to this is we're going to throw a 2 on each one of these. Why do we do that? Well, if we multiply these two parts out, we're going to get that x to the fourth that we had in the original problem there. If I take the 4 and the x squared, that's going to give me a 4x squared. And I take this right here and multiply it, that'll give me a negative 5x squared. And that negative 5 and 4 will give me that negative 1x squared that we had right there. Sorry. Okay, and then lastly, the negative 5 and the 4 just gives me the negative 20 right there. So you can kind of see where this is going here. It says to write the as a product of factors that are irreducible over the rationals. So when we look at this right here, we've got x squared minus 5 and then x squared plus 4. If I was to take and solve this first part right here, we would have x squared minus 5 is equal to 0. That would mean that x squared is going to equal 5 and x is going to equal plus or minus the square root. Of 5. So irreducible over the rationals, this part of it says we're going to have x minus square root of 5 and x plus square root of 5. And then we'll have this x squared plus 4. And then for part B here, it says u as the product of linear factors and quadratic factors that are irreducible over the reals. Okay? And so I actually jumped the gun here. Sorry, we're going to put this answer down here. Okay, sorry. So we got the product of irreducible over the rationals. We got our irreducible quadratic and another irreducible quadratic. One is going to be real, one's going to be imaginary. This is the irreducible first part here. So now it says let's factor this completely. That x squared plus 4 is going to equal 0. That means that x squared is going to equal negative 4, so x is going to equal plus or minus 2i. So now that means factored complete would be x minus the square root of 5, x plus the square root of 5, and then x plus 2i, and x minus 2i. That's the completely factored linear form of this solution. Okay? All right, a couple more here, and then we're going to be done. These are pretty quick notes because it's the same stuff as what we've been doing. All right, for this one, it says find all the zeros of the given, find all zeros of this function. There's a typo right in here, of this function, given that 1 plus 3i is a 0 of f. So right away, they're telling me something. We know that one of my zeros of this is 1 plus 3i, so we have one of my 4. We actually have 2, though, because what happens is, remember, if we have an imaginary solution, that means we've also got its conjugate, which is 1 minus 3i. Okay? Now, there's 2 ways that you can go about doing this. You can do long division, or you can do synthetic division. I personally hate long division, as I've said in previous ones, so I'm going to use synthetic division for this. Okay? So let's dive in. Let's see what we can do here. All right? If we know it's a 4th degree polynomial, we have a 1, negative 3, 6, 2, and negative 16. Look at the degrees. 4, 3, 2, 1, none. We've got all degrees to count for, so there's no zeros that have to be added in here. Let's start first with 1 plus 3i. Now, this is not fun to work with, but it actually still works out pretty well. Okay, you'll see. Bring it down. Let's multiply, and we're going to have 1 plus 3i, which will give me negative 2 plus 3i. Now, we're going to have to multiply 1 plus 3i times negative 2 times plus 3i, sorry. And so I'm going to go ahead and just kind of jump ahead here. You guys can multiply that out, but if we're going to do 1 plus 3i times negative 2 plus 3i, okay, that's going to give us a negative 11 minus 3i, which will give me a negative 5 minus 3i. And then we're going to have 1 plus 3i times negative 5 minus 3i, which will give me a 4 minus 18i, which will give me a 6 minus 18i. Okay, that's just multiplying, adding. And then we're going to have that times 6 minus 18i, which will give me a 60, which will give me a 0. So we already know that one of the zeros is 1 plus 3i. Synthetic division right here just proved that this is in fact a 0. So let's do it again. This time we're going to use that second factor that we have, which is the 1 minus 3i. Okay, we'll bring down the 1, multiply these together, we get 1 minus 3i. Okay, add straight down, we end up with a negative 1, and then these actually cancel. Multiply the negative 1 minus 3i, which will give me a negative 1 plus 3i, which adds straight down, we'll end up with a negative 6. These cancel. And then multiply the next part, we're going to get a negative 6 plus 18i, which these will just cancel and cancel, so we're left with a 0. So if you recall, what happened was we started with x to the 4th power. And then as we worked, we divided, now we're at x to the 3rd. And now we're at the point where it says x to the 2nd. And we start with x to the 3rd here, then we divided, we got to x to the 2nd, and now we're down to where it says x. So when we look at this right here, this is a quadratic that just says x squared minus x minus 6. We can finish solving this. X squared minus x minus 6 equals 0. I'm now at the point where it's a quadratic that I can use all of my tools. I could factor it, I use a quadratic formula, whatever I can use to try to solve this, completing the square even. This fortunately, actually factors out nicely. Then we get x minus 3 and x plus 2. So we get x is equal to 3 and negative 2. So it says to find all the zeros. Well, we've got all of our zeros. 3 and negative 2 are my two real zeros. X equals 1 plus 3i and 1 minus 3i are my complex zeros, my imaginary zeros. Okay, let's confirm this, that 3 and negative 2 are my solutions here. If we look at this picture here, you'll see that at negative 2 and positive 3 are in fact my two solutions. All right, one more question here, and this one's a little bit of a doozy, okay? So this is the first time we're actually seeing this where it actually gives me a point. And by giving a point, what that does for us is it actually forces a direction. What I mean is that when you're given a certain point, it forces a stretch or a shrink to take place within the picture. So let's just see what happens here as we start to work through this, okay? We are given first that it's a fourth degree polynomial. So there have to be 4 factors for this, okay? One of them is that x is equal to negative 2. One of them is going to be x is equal to 1 plus 3i. Its conjugate is going to be x is equal to 1 minus 3i. Now, where's my fourth one? The only way that we can make this work is it would tell us what the other zeros are. The only zero that they don't tell us, because it's actually repeated, is if this negative 2 has a multiplicity of 2. So that means we're going to have in our picture a turning zero that's going to take place. Okay, so these would be my 4 zeros that we're going to use. And it says write the function in a completely factored form. So we're going to have x plus 2. We're going to have x plus 2. We'll have x minus 1 minus 3i. And then we have x minus 1 plus 3i. And then it says to write the function in polynomial form. We got to multiply this whole thing out. Okay, so eek. Let's do it. So for this first part here, multiplying the real parts out, we're going to have x squared plus 4x plus 4. That's the easy part. Now that x minus 1 minus 3i, we've done this in the past where you actually can make like a nice little chart to help keep yourself neat and organized with all this. Okay, that we're going to have x minus 1 minus 3i and x minus 1 plus 3i. We'll get an x squared, a minus x, minus 3xi, and then we're going to have a negative x, a positive 1, a positive 3i, a 3xi, a negative 3i, and then a negative 9i squared. Okay, bunch of stuff's going to get rid of itself. Negative 3xi and positive 3xi's cancel. Positive 3i, negative 3i cancels. That negative 9i squared is going to turn into just a positive 9. And so we end up with multiplying this out, x squared minus 2x, and then plus 10. And again, that 10 is going to come from the 1 that's here and the 9 right there. So that's our 10. So now we have to finish multiplying this entire thing out. I'm going to do the vertical method rather than the Punnett square for you guys, just so you can see it in action. Vertical says we're going to take the x squared and we're going to multiply it by this trinomial here. So that's going to give me x to the 4th, negative 2x cubed, and positive 10x squared. Okay, so we'll have x to the 4th, negative 2x cubed, and then positive 10x squared. Now we're going to take that 4x and distribute it to everything on the right side. So we're going to have a 4x cubed, a negative 8x squared, and then a positive 40x. Okay, so we're going to have a positive 4x cubed, a negative 8x squared, and a positive 40x. And hopefully you can tell what I did here is I lined up the like terms. And then the last thing we're going to be multiplying here is going to be this 4 is going to be multiplied by the stuff over on the right here. So we're going to have a 4x squared, a negative 8x, and a positive 40. So we're going to have a 4x squared, a negative 8x, and a positive 40. Let's put all these together. And we're going to have x to the 4th plus 2x cubed. That's 14, so that's going to be 6x squared plus 32x, and then plus 40. But wait, there's more. I'm like a car salesman or like one of those infomercials. But wait, there's more. So we've created the function in this. Problem is we're not done. Okay? I need this point to be a part of my solution. By them giving this to me, remember I said this forced our hand and said there's going to be something that's going to take place. This point can cause my graph to flip over. It can be stretched. It could be shrunk. We don't know what's going to happen until we actually plug it in. So -4 and -408 has to be placed into this. Well, what letters are they giving me? Well, here's what they're giving me. They're saying when x is equal to -4, y is going to equal -408. When I input a -4, I get a -408. Well, what does that mean in this problem? Remember that in reality, there's this entire problem that we had here, this entire thing that we had. But here's the deal. We actually have an a value in this problem. We haven't had a problem where there's that a value being manipulated. This is a problem where it actually gives it because of that point being added into this. So we have to solve for that a value that will cause a reflection or stretch or shrink. So when x is equal to, what was it, -4, we get that f of x equals -408. Okay, so let's plug this in. -408 is equal to a times, this will be -4 to the 4th power, plus 2 times -4 to the 3rd power, plus 6 times -4 to the 2nd power, plus 32 times -4, plus 40. Okay, let's throw all that into the calculator and see what we end up with. So -4 raised to the 4th, plus 2 times -4, raised to the 3rd, plus 6 times -4 to the 2nd, plus 32 times -4, plus 40. And we get 136. So -408 is equal to a times 136. Divide both sides by 136. Dude, I totally just realized I was blocking me. I'm always in the way. So we get 136 there. And if we do -408 divided by 136, we end up with a is equal to -3. There's my answer. So now let's put it back with the function that we have here. We have -3 times x to the 4th plus 2x to the 3rd plus 6x squared plus 32x plus 40. Okay. And what's going to happen is, if we were to go ahead and distribute this out, we end up with a -3x to the 4th plus, minus 6x to the 3rd minus 18x squared minus 96x and then minus 120. So it's that U-shaped curve because it's x to the 4th, and with that leading coefficient being a negative, it flips it over, and with it being a 3, it's going to go ahead and vertically stretch it out. So let's see if it matches all that in our calculator here. This is my function flipped over. It's very narrow rather than being very wide. It's very narrow because the ends were pulled and stretched out. If you notice here, it's got that turning 0 at -2. And even if I zoom out on this picture, you'll see it continues in that direction forever. Okay, now here's what we're looking for. Is this point a part of my solution? -4, -408. And you'll see there it is, right there, my point. Okay. That is it, folks. I hope you guys followed along with this. Again, watch any parts that you need. Most problems are exactly the same. If you struggle with how to input them, just go back and follow the directions. Look at the examples. But if you have any questions, please don't hesitate to reach out. Otherwise, you guys take care. Be safe. Be respectful. Be responsible. Like and subscribe. And have a great day.